Understand how potential energy relates to atomic interactions. When two isolated atoms are far apart, they do not interact, and the potential energy of the system is close to zero. As they approach each other, electrostatic attractions between the nucleus of one atom and the electrons of the other pull them closer, which lowers the potential energy of the system. Identify the stable bond configuration, energy minimum, the lowest point, the absolute minimum, on the potential energy curve represents the most stable state for the two-atom system. At this position, the attractive forces and repulsive forces between the atoms are perfectly balanced, making the net force between them exactly zero. This stable state corresponds directly to the formation of a chemical bond. Locate the bond length on the graph by examining the provided potential energy diagram. The minimum potential energy, the bottom of the well, corresponds to an internuclear distance of exactly 75 picometers on the horizontal axis. Therefore, the atoms form a stable bond with a bond length of 75 picometers, which identifies option B as the correct answer. Determine the nature of the forces at other distances. Internuclear distances shorter than the minimum, e.g., 25 picometers if the atoms are pushed closer than the stable bond length. The positively charged nuclei and negative electron clouds repel one another strongly. The potential energy rises sharply, meaning the net force between the atoms is highly repulsive. Internuclear distances longer than the minimum, e.g., greater than 75 picometers if the atoms are pulled farther apart than the stable bond length. The electrostatic attractions pull them back together, meaning the net force between the atoms is attractive. The correct answer is option B. The atoms form a bond with a bond length of 75 picometers.